Okay, we can start.
Okay, just a second, sir. Okay, good evening, everyone. So we have with us today a very honorable speaker, Mr. Atanu Choudhury, and he is an IoT evangelist and founder of Capsule Labs. He was a techno-functional consultant for IoT or artificial intelligence-led digital transformations, providing delivery and solutioning support to Altiax's global sales team. Prior to Altiax, Mr. Choudhury was a member of technical staff at Infosys Set Labs, Harvard Sensor Networking Lab, Telcordia Advanced Technology Solutions Lab, which is now Ericsson, and Blue Highway. He has postgraduate degrees in computer science from IIT Guwahati and Harvard University, and he is a senior member of IEEE and the Computer Society of India. He has published over 35 papers and patents in the area of IoT and wireless sensor networks and has provided consultations for over 100 IoT-based solutions globally. So with this, I request you, sir, to take over the session, and we first of all welcome you to our MHRD IIC of Narula Institute of Technology, under which this seminar is being conducted. So, sir, please.
Thank you, Professor Rupa, for that introduction. A very, very warm welcome to everybody who's joining us from various parts of the city today. Before I delve into this discussion, I graduated college in 2003. And since then, I have been part of corporate research, of academic research, and over the past 10 years on, I've been looking at solutioning using IoT and commercialization of IoT products. Right. So that's the background with which I wanted to have this discussion around the Internet of Things and the innovation that it is bringing in today's life. Unfortunately, as I just found out, I have a few slides, I have a few videos that I wanted to show, but we will not have audio, so we'll kind of talk through it. So instead of talking about IoT or trying to define IoT, what I'll do is I will try to describe the characteristics of IoT. And this talk is designed to be about 45 minutes, so I will take questions after that. However, if there are any pressing questions, please let me know. Okay. So the first characteristic that I wanted to talk about is that IoT is nearly invisible. You don't see it around us. I have a small video. You cannot hear the audio of this, but I'll let it play. So I'll summarize that ad a little bit. Parents who are extremely careful about their children, and they will go to any extent to look after their well-being. Even there is a lapse of concentration every now and then, right? And every time there is a lapse of concentration, there is the potential for unfortunate human loss. That is where you want machines, that is where you want devices to be looking over your shoulder and kind of even override human human actions. So that's the essence of that ad. The next thing that I wanted to talk about is that IoT is something that is connected at scale. There are a very large number of these computing devices that are there everywhere around us. But it wasn't always so. So it's something that has happened gradually over time, and we can dig into the timeline to see how this scale kind of came about. In the late 80s or before the 80s, you had mainframes, and people used to vie for timeshare on those mainframes. There were many people who were looking for time on that mainframe. And then by the late 80s, the personal computer had come about, and there was one computing device or one profile per computing device. One user was using it. By the mid 90s, laptops had become popular in the business community. So business leaders who were moving all around the world, they had access to corporate data on the go. That was a big movement in terms of computing going mobile. But it truly went mobile in the 2000s when the mobile phones started to come into the market with limited internet connectivity in forms of edge networks or 2.5G networks, feature phones. Over time, 2005, the Orkuts and the Facebooks of the world, they started to come into the picture, and a lot of internet access was actually being driven by people wanting to access social media on the go all the time. So you saw these apps starting to come into the market. The next big development was in the 2010s, in the next five-year horizon, when the whole mobile screen was being used for internet access, and a lot of e-commerce started to pop up on the mobile phones, leading to an explosion of apps that was vying for space on this small screen. These apps were started by small companies which were taking on the might of very large organizations, and it was essentially what was founding the gig economy. So companies like Uber, like Zomato, like Ola, Airbnb, all of these were becoming very massive companies, very highly valued companies. And all of this was being enabled by a sensor on the end, on the user's device. It was the mobile phone, and then there was some kind of a location device or something like similar, which was there on the service provider's side. So already you see a lot of these embedding of computing going on all around us. Today in 2020, what we hear is a lot of smart city projects around us. Lots of sensors all around the city that are producing small amounts of information, but together they are providing a better service for its citizens, and uh, the payment mechanisms is going cashless, is going digital, right? From earlier on, when you had internet banking and it was a tedious process to go about and do that, to the kind of UPI and QR code based payment systems that are available today. So there is a synergy between a lot of these payment platforms and the service and the way the services are being consumed in very small volumes. So smart cities, I have a video around smart cities, but if I go to a city like even Bangalore today, where most of the public transport system is equipped with a location-based service, so I can step out of my house only when I know that the bus is near my bus stop, or I can book a cab and I know that it will come and pick me up. If I look at vehicles, mopeds, bikes, cycles, all of them are part of what is called a shared economy. I can use an app and book a cycle and pick it up from anywhere I want, right? So these are kind of new services that are getting enabled. So what this means is that there is a larger number of people who are starting to use or consume these IoT services, and each of these people are consuming it more and more. So that is why there's an exponential increase in the number of digital interactions that are happening, both due to increased penetration and due to the depth of usage. So I want to hold to that thought of digital cities being able to generate about $2.4 trillion. That's just the service revenue. It's not, that's larger than essentially the GDP of the entire, the entire of the Indian subcontinent. And the way that is happening is there are sensors that have been put out in the field. There are people who are a large number of IoT field engineers who are going out into the field and actually going and installing these devices. These devices have to be managed to ensure that they get power supply, that they get connectivity. The connectivity has been provided by different service providers. These the towers have to be installed, so there is a huge field force that is going into the deployment and managing of these assets. And finally, the IT infrastructure, which is collecting this information and distributing it for the consumption of the citizens. So that is how IoT is becoming embedded everywhere, and it is becoming disruptive. It's disruptive not only in the context of a smart city, but it is disruptive in the context of consumer electronics, a lot of new devices that are coming into the market, as well as it is disruptive in the area of manufacturing as well. I think this was another nice video, but without the audio, this might get a little lost. But I'll go ahead and play that. You'll get a sense of what's going on because personal electronics are changing quite a lot. App-based uh, smartphone, coffee machines to blinds to ovens, smart thermostats, smart inventory management. And this is an example from the industrial space where these automated guided vehicles are becoming more and more prevalent. Here, the discussion is around there being no downtime in an IoT-enabled shop floor. Uh, even if I look into the manufacturing sector, you see a lot of which was traditionally Modbus and SCADA controlled devices. They are getting automated. They are getting to send a lot of their transactional data back to the cloud, where this information is getting processed. Now, to give you an example of the complexity and the innovation that is required in the IoT space, let me take an example of switching on a bulb. There was a popular joke which said, "How many engineers does it take to switch on a bulb?" So at this point, what is happening is bulbs are getting smart. So it's a lot of gesture control. It's a lot of voice-based control that is coming in, where Smart bulbs are available for 500-600 rupees today. They are commercially being produced. In any of these bulbs, there is a commissioning method. There is a commissioning method which is over either a Bluetooth or some kind of an out-of-band network, which is used to configure the bulb with the access credentials of the router. And once that happens, the bulb talks to the device cloud, the manufacturer's device cloud, and registers with the cloud so that only one person can use it. Thereafter, when somebody comes in and says, for example, Alexa, switch on the lights, uh, what happens is there's a piece of hardware in the smart speaker which is waiting for this wake word called Alexa. And the moment Alexa comes on, it waits for the remaining part, which in this case is switch on lights. That's how it captures that voice packet and sends it over to an Amazon's conversational platform, where uh, there's a lot of natural language processing that needs to happen, a lot of context that needs to be translated. And switch on lights in any kind of accent has to be converted into the text which says, okay, this is the action that we want. Now, with this action, we now need to figure out who is this person who has issued this particular command. So there is some kind of a user profile lookup so that we know what is the device that we are talking about here. And if this device has a switch on skill, right? If so, it will look up who is the manufacturer of this particular device and ask this particular cloud. It will kind of log into this particular cloud and said, hey, switch on this user's device. When this call is made, the device cloud also knows who this user is now, and it has a mapping saying, this particular user, what is the device ID that is associated with this particular user. So it looks that up and checks with what is the current IP address of this particular device. And this particular device this bulb could be sitting behind your home firewall. This bulb could be sitting behind your router. So it's got a very private address by itself. But this is registered with the cloud, and IoT kind of enables, this is one of the very fundamental innovations in IoT, where it enables the cloud to talk with devices which are behind firewalls. It uses a brokering service for this, but we'll not get into that today. But it looks up this IP and actually sends it a command saying that, hey, switch on. On receiving this command, the bulb will actuate, and it will send back an OK response, typically in the form of a small message. This message is interpreted by the device cloud, and it sends back an acknowledgement for the API that was called from, or application programming interface that was called from Amazon. So Amazon says that, hey, everything is okay, the bulb switched on, so it must respond back. So it converts this acknowledgement into a voice response, sends over an OK in a voice packet, and that is kind of played back as media on the smart speaker. So what is important here is a small action like asking Alexa to switch on the bulb is interacting with so many different components and so many different pieces of hardware, so many different independent systems. Building this kind of a system is very, very innovative. And within this platform itself, there are smaller pieces of innovation that goes in terms of what is the, how soon can I translate and capture the voice packet? How soon can I wake up? If I change this word from Alexa to something else in some other language, how will it respond? How will the system respond to voice from kids or voice from people with heavy mother tongue influence? How to do this natural language processing. So there's a lot of AI that happens over here. There's a lot of power management and connectivity issues that are getting managed in the bulb itself. So there is a lot of innovation that happens at various components of this entire solution. But what I wanted to leave you with is an understanding that even a simple looking phenomena like switching on the bulbs can take now many engineers, and it involves interaction through various platforms. Naturally, building such an interconnected system means that the system is interdisciplinary. And when I say interdisciplinary, a lot of these aspects are part of computer science courses, right? Some of them are algorithm design. There is the natural language processing is part of AI and data science. There is mobile app development that is going on for the user interface. There is web development for the administrative system through which the system the system can be managed. There is security that is coming into the picture because the devices have to register themselves appropriately. Uh, an adversary cannot be allowed to go in and control the smart home. The device cloud and the conversational platforms that we saw, they are hosted on cloud systems, which are essentially large banks of data centers. So they have to be managed. So there is definitely a lot of computer science aspects that go into it. But that's not the only part, right? Because it is interdisciplinary, it means that it also ties in aspects from other disciplines as well. For example, if I look at the electronic segment, uh, there is, by the way, this is a robot called Atlas by Boston Dynamics, and this has about 42 different joints, hydraulic joints. This system can learn from being able to just balance itself to being able to do Parker backflips and landing on its feet. It was able to do that in a few months' time. That's how soon it is learning how to coordinate its movements. Uh, there's a lot of electronic components, there's a lot of sensors, there's a lot of power supply, right? So a lot of this interfacing has to be done for IoT devices, which are typically constrained devices. They have limited computational capabilities, they have very limited power available to them. Mostly they're battery powered, there's very little memory available to them. So a lot of these peripheral devices have to be integrated over, say, a SPI interface or an I2C interface or a GPIO interface, depending on the application that you are trying to build. The other aspect is the communication part of it. These devices must have some kind of a backhaul, but not all IoT applications need the same kind of backhaul. So some of these applications which are oriented towards augmented reality or virtual reality, they will benefit a lot from technologies like 5G that are coming into the market, which will provide a very high bandwidth to these devices. But in a lot of cases, if I wanted to, for example, read the electric meter in somebody's home, I do not need that kind of bandwidth. I need to be able to do 1 or 2 meter readings a week or maybe once a day. That's about the kind of bandwidth I require. So there are these new technologies that are coming into the market called narrowband IoT or Sigfox, which are provided by operators for enterprises which have devices which are kind of limited in a particular geography. There is a technology called long range or LoRa. Similarly, uh, on the you don't always need to connect the devices over very large networks. So sometimes they need to be able to talk only over a few feet or a few tens of feet. In which case, low power Bluetooth or Wi-Fi or technologies like Zigbee come into the picture. Uh, Google has been developing a protocol called Thread, which is essentially trying to abstract away the way the radio access happens. So Thread kind of sits on top of whatever radio you choose and provides a UDP interface to the rest of the system. So there are lots of radio options because the devices are extremely power sensitive. They're very limited power budgets. There are various kinds of antennas that are getting designed. This could be, PCB trace antennas. This could be ceramic antennas, right? This could be external antennas which are connected through pigtails. So a lot of antenna design goes into the development of IoT-based solutions. The third aspect is around being able to really miniaturize the sensors themselves. And a lot of MEMS technology is being used for both sensor designs, like making of accelerometers and stuff like that, as well as very small, miniature motors and drives and stuff like that. This is actually a picture of a MEMS micromotor. As you develop IoT solutions, some of these platforms like Raspberry Pi, they come with a pretty much a full standard Linux operating system. But what happens there is the cost of the device goes up because the system requirements for running an operating system may be very high. So in a lot of cases, when you are trying to build a system which is really low cost. For example, somebody came to me with a proposal for making a connected mosquito repellent. A mosquito repellent itself is probably 60 rupees. Adding Wi-Fi connectivity on a mosquito repellent, and the total budget for the project was about 120 rupees was the final price that they were looking at. So 60 rupees for essentially AC to a 5-volt conversion. So the power modulation, the embedded code that was going in, the Wi-Fi chipset, and the antenna put together. That's the kind of request that I have gotten. And in those cases, what happens is you cannot run a full-fledged microcontroller or microprocessor. So you have to work very close to the bare metal. You have to work with very proprietary tool chains, which allow you to write code that is almost near assembly. So that's another skill set that is very much in demand from the embedded world. Finally, all of this come together. Companies like Flipkart today are using a whole fleets of such devices where, in this case, Flipkart introduced these automated guided vehicles for its sorting facility in Bangalore, where each of these robots can move around, they pick a parcel and they drop it to a bin corresponding to the final destination, to the destination pin code. Similarly, in biomedical devices, I've worked with a biomedical company for a while. There are consumer grade or clinical grade devices like continuous glucose monitoring systems, which are available today. Even implantables. Medtronic is one of the leaders in making pacemakers, and they are coming out with Bluetooth-enabled pacemakers, so that a patient can, the pacemaker configuration can actually be changed post-surgery. And just imagine, I mean, people not having to go through another a completely redundant surgery because the configurations needed had to change. That's a boon. That's a big blessing. Similarly, it is coming into the world of textiles, wearables, where there are smart shoes with auto lacing capabilities, which kind of control the humidity within the footwear. It ensures that there is no damage to the foot. It ensures that it collects a lot of data about the walking styles and patterns, and essentially prevents a lot of injuries. Nest is a company that completely redesigned the consumer electronic space with its set of thermostats, connected thermostats, especially in countries where there is both the requirement for a heating system and a cooling system. This became very popular and was eventually acquired by Google or its parent Alphabet. The examples don't stop. The automotive sector is one of the biggest adopters of IoT. They have been using automated robots for the assembly lines, and today pretty much every vehicle is equipped with a FASTag system that allows for automated tolling. There are also a lot of off-the-shelf or after-sales solutions like tire pressure management systems, which will collect the tire pressure from large trucks and send over any kind of anomaly to the fleet owners, so that they can rectify a problem before a truck flips over and there is much more catastrophic damage. Same in the case of renewables, whether we are talking in terms of solar power, whether it is hydel power, in this case, wind turbines. There is a lot of instrumentation that is going on in the turbine itself to kind of understand the impact of very high winds on these turbines. If there is any kind of shears that are going on, the condition of the ball bearings inside, if there is any slippage that is going on between the gears. So these are the kind of systems that are measured within the turbine, and if there is any maintenance that is required, the turbine can be switched off and it can be maintained before the whole thing collapses. So automotive, renewables, any sector that you can think about, there is an IoT solution that is there today. Much like the much like the previous example where I talked about measuring the shear forces on the turbine, structures have to be monitored so that they are not undergoing damages. Large skyscrapers, large bridges, they need to be monitored for structural health, whether it is coming from a seismic activity or there is resonance within the structure itself that is causing the structure to move beyond the flexibility of the internal steel capability. That is something that can be measured, preventing another catastrophic damage. Similarly, we are seeing applications in construction where building materials are becoming better. For example, curing of cement. This is a company called Volker Vessels, which has this solution for measuring if a large piece of concrete, prefabricated concrete, especially being used for dam construction and large building construction, has been properly cured before they have been taken on to the site. So we'll see similar kind of applications also coming up with the advent of smart glasses, and there's a whole network that monitors how a glass should behave, if it can tint, if it can save energy by preventing UV rays from coming into the building and requiring extra cooling from the HVAC system. We also see that in the architecture side of things, where large buildings, the facade lighting is being changed. The photo below is of FC Bern, and they have their stadium, which has acoustic sensors linked to the display panels. So the lighting outside mirrors the excitement and the noise that is going on inside. So all these applications, I know I repeated a lot of these examples talking about the connectiveness of these solutions, but all these examples are about finding out a solution which did not exist, completely new solutions. So which is why IoT is very, very innovative. And it is innovative because it allows us to automate. It allows us to, for example, if I wanted to leave my house and switch off all the lights at one go, it can allow me to do that. So that's just a robotic process. It allows us to do real-time things, like the example that I showed with Volvo, where the braking system or the lane changing can be controlled by an IoT-based system. It allows us to make recommendations, just like when we want food, we want instant gratification from a very large list of options. So in case of machines on the shop floor, the operator will see a very large number of variables in front of them, from valve parameters to electrical parameters, and the system can make recommendations of the next best action that the operator can take, looking at the optimality of the scenario without making that change itself. Then it gets to learn. It gets to learn our communal behavior. A typical example I like to give over here is about GPS systems. And when you use the traffic lighting, when you use the traffic mode, if you see a red light if you see a red patch on the traffic map, you know that it is crowded, and you get that information because other people there, their velocity is slow, and that information is what is coming back to me to help me decide whether I want to choose that particular path or not. So it learns community behavior from a one-to-one interaction to a one-to-many interaction to a many-to-many interaction, where this self loop is completed and gets optimized. And finally, if it learns this information, it can make predictions. It can make predictions about our unvoiced needs, where we may not want that, we may not really realize that we are looking for something, and that's the kind of predictive maintenance that starts to come into the picture. So large complex systems like very large motors, several hundred kilowatts worth of large motors, if they fail, then the entire plant is going to shut down. But with predictive learning, we get to know if there is maintenance that is required, or it allows us to kind of bring those components in advance so that there is no downtime. That is very, very important. So that's why we need this innovation. And when we talk about innovation, we really have to look at how is this innovation going to get priced. You can build something, but if that IP can be in the form of a trademark, of a trade secret, or it can be a business process, or it can be in the form of a patent. Right? But if that IP has not been commercialized, you will not get a lot of value for it. So that's why it's in the negative value space, and there are limited buyers, but there are a few buyers who will take this up. And then there is a way to evaluate the price of this IP based on a cost approach. How much did it cost us in terms of licensing fees, in terms of legal fees, in terms of R&D, in terms of material costs to go ahead and build it? If I sell something at a cost approach, then there will be many buyers for it because the cost is low, but I'll not get a lot of value out of it. The second approach is the income approach that talks about what is the potential savings that a company would make if they brought that IP, or what is the additional revenue stream that they will generate because of that particular IP. So that's a way to measure the that's one way of measuring the value of an IP. But the most lucrative one is the market approach, where we look at not what is the immediate value of that particular IP, but what does it help, what is the competitive advantage that you get because of that particular IP, right? So to take an example across these three things, all of you are familiar with using WhatsApp, and one of my friends used to work at Google when Google bought over WhatsApp. So he moved to WhatsApp, and he was part of the core team there. So they were about, when he joined, there were about 30 people who had been developing WhatsApp for about 3 years. So that's about 100 man months worth of effort, 100 man years worth of effort. Even if the engineers were paid, say for example, $1 lakh each. So if we took a cost approach to this, then $100,000 into 30 people into 3 years would probably work out to be about $10 million, right? So if they took a cost approach, the pricing would have been around $10 million. If they took an income approach, probably WhatsApp at that point wasn't making a lot of revenues, but with its ads and payment systems, it may make about $50 million, right? If it is making $50 million, then at 10x that price, 500 million would have been a good pricing for it. But Facebook paid $19 billion for it. And that is not because of what WhatsApp was worth to them, or what WhatsApp would make for them, but it was more to prevent Google from getting access to that large base of users in areas which Facebook did not, or in demographies where Facebook did not have a reach. So when you price a particular IP, you look at these three parameters and then arrive at a practical valuation. Where do you want your product to be placed? So if you want to go with the market approach, then of course there has to be more risk to it. So if I look at what drives innovation, it's again a matrix between the value and the risk appetite. In most cases, it is a process innovation. For example, a few years ago, I don't know how many of you actually stood in line to pay the electricity bills, but you had to do that, and you had to pay there in cash. Then the discoms, they allowed us to make payments over internet banking, and today you can make a UPI based payment. So these are all process innovations that help simplify the transaction between the consumer and the provider. A lot of products, they will continue to bring out new features and functionalities, and they have to maintain what is known as a product S curve, where every innovation drives new sales. Of course, there is curiosity and necessity that is not connected with the market dynamics, very reminiscent of Professor Shonku making what he wants to make, and that drives a number of innovations. A classic example over here is probably Ray-Ban, and Ray-Ban was developed as part of NASA's projects to essentially create a UV shielding light for its astronauts, but it eventually became a huge commercial success. But where I want to draw focus is over here in terms of new service offerings. Making such an offering takes on a huge amount of risk, but the value that it can realize is completely new markets. And the only way to know that something is valuable is to test it out in the market. large companies like GE have made mistakes where they put together an industrial IoT platform called Predix. They put in about 300-400 people, very, very highly paid data scientists and AI engineers, and the platform was very expensive to operate. So with the huge risk, nothing really materialized, and essentially the team got decommissioned. Whereas something like an Uber, which solved the practical problem, has now scaled up to a several tens of billions dollars worth of valuation. So new service, if somebody is very sure, there is a huge risk associated with it, but the value that you get out of it is very, very high. And that's where IoT kind of de-risks a lot of things, because it is inherently future ready. And when I say future ready, how do you become future ready with IoT? The characteristics that I talked about, right? The near invisibility, the being connected at scale, being disruptive, being interdisciplinary. None of these are all non-functional requirements, and they are not really part of any current curriculum. Right? Because they're not, the only way you get to learn about this market dynamics of where an innovation can take you is by doing multiple projects. It's by doing projects that you are really passionate about. Because if you want to get valuation out of your solution, then you have to be pursuing it day in, day out, and that will not happen unless you are passionate. If that allows you to kind of develop on skill sets which are in demand in the market, or what we call our market gap skill sets, even better, because there is value that you are generating for yourself, and projects that can solve a problem. There are a lot of knowledge bases. There's a lot of open source, open courseware that is available. There's a lot of literature that is available. There's a lot of YouTube tutorials that are available. Leverage those knowledge bases. That is what will, when you go into the industry, what matters is how you are able to solve a problem, where you pick up those information from. Nobody's going to ask you a Lagrangian formula or an FFT translation. They're going to expect you to go in, look at a video, find that out. You have to understand what collaboration is. You have to understand how to negotiate project scope. You can, when you start doing a project, you realize that there's a lot of complexity in it. So you have to be able to tell the other person that, look, this is beyond the current timelines that we have signed it up for. And learning that negotiation is a life skill. You have to be convinced. You have to be convinced about what you are doing, and you have to be able to present it to somebody, to an audience, so that they can understand it. And finally, you need to have certifications or proof that the work that you're claiming to have done has actually been done. So a mere certificate will not help you, but certifications which talk about what is the project you have done, what tools you developed, you used when developing that, where is your source code, or where is the proof of that particular experiment? If you got published? These are, if you are able to make a YouTube video about your project, these are what really makes you a very, very attractive candidate for a potential hire. So what's the future of an IoT engineer? The IT industry has been in India for close to 30 years now, right? And it has grown from, it was about 600 billion last year, and it is expected to grow to about 1.1 trillion by 2025. Whereas the IoT industry is about 212 billion and is projected to grow to about $1.6 trillion. That's almost a 25% or 28% compounded annual growth rate, with managed services growing even faster. Where are these services coming in? They are coming in terms of being able to deploy the IoT solutions, right? So a lot of embedded engineering and systems engineering work is coming into the picture. A lot of field engineering is coming into the picture. Today, probably one of the largest companies that does a lot of field engineering is a company called Quest, which sets up a lot of network towers. Right? Once you do one or two projects, you become an IoT developer with a skill set to essentially move across the entire value chain of IoT. And once you start doing multiple projects, this may be not now, but as you develop more and more expertise around it, you can become a solution architect when you can talk about the various options that are available to you in terms of building a product. And finally, I hope that one day all of us will be able to move this discussion forward and become entrepreneurs by yourself when you have understood and created that particular solution that you really want to take to market and you want to sell. Right? That's where you become an entrepreneur. So if you want a future-ready IoT career, it gives you a first mover advantage because the market is still small. There's definitely better entry-level compensation. the kind of IoT projects that are coming into the market, it is very, very disruptive. Everybody's trying out a new idea. Some of them will succeed, some of them will not, but it's whatever happens, it is very inorganic. It is very, you get a lot of visibility within the organization if you do these projects. And it doesn't take away from your core areas. You have to build on the 4 years that
Sir,
you are.
just let me interrupt once.
Yes.
I just want to ask Shubham Chandra, who is that? Please mute yourself. Yes. Okay, sir.
Yeah. So I'm almost done. So I'll take questions after this. But the point that I was trying to make is if you become future ready, it allows you to build on the skill sets that you already have. It allows you to leverage your electrical background or your civil background or your architecture background, whatever, the 4 years you are investing in your engineering program. It allows you to build on top of that and either go ahead and work in similar solutions in those fields, or start to commission solutions in these areas, right? It doesn't take away. So my point is, it doesn't take away from any of your current opportunities, but it kind of adds on if you want to explore this area. So what are the kind of companies that are recruiting? A whole lot of semiconductor companies. All of them are employing more than 5,000 people in India. So a lot of semiconductor companies, this is just a snapshot. There are close to, I would say, about 70, 75 semiconductor companies, some of them fabless, some of them with fab. A lot of connectivity companies, they are all investing in their LoRa networks. Tata Communications is one of the largest providers of LoRa. Jio has been working on its narrowband IoT. Jio and Airtel they have been redeploying their 2G network into a narrowband IoT network. Vodafone has been partnering with a very large number of companies all across the globe in their M2M solutions. Right. Sigfox is a French company that provides very. They take you away from these monthly contracts. You pay based on the number of transmissions that you make. There are a large number of cloud companies which are also which are looking for IT engineers, which are looking for DevOps engineers. But then there are the solution companies, which are again companies which make products by themselves. A lot of networking product, a lot of PLC products, a lot of electrical products, a lot of home networking, IT networking, and Bosch is in the manufacturing segment. Servicing them, a lot of what we call solution engineering companies, which will build out the front end applications for them. But any of pretty much all the large players in the market are investing in some form or the other in IoT, and that's where I think that there is a lot of scope for innovation and employment. Right. So that's essentially what I had to bring to the table.
Okay, thank you, sir, for your wonderful lecture. Now the forum is open for discussion, and the students, you may please ask questions to sir. Any questions?
So, sir, you are an entrepreneur.
Yes, I am. An entrepreneur really is I have been working in the area of IoT for the past almost 17, 18 years now. And over this time, I have been building so many solutions that I realized that there is this big gap that is coming into the market. And this is where a lot of employment can be generated. So I help people, a lot of students, a lot of job seekers to kind of build on their resumes by doing IoT projects.
Okay, Rituraj, you had got something to say. Rituraj, I think you have written something in the chat box. Can you please ask, sir?
Rituraj had a question. He says that he had made a car.
Yeah.
But I did not follow your question, Rituraj.
Yes, it's incomplete, I think. Rituraj, please ask the entire question to sir. Whether it can be called as an IoT product.
The way I look at IoT is a paradigm. IoT is a paradigm which says that the data that was being collected in in a device was earlier siloed within the device. Nobody had access to that data. The moment anybody in the world can have access to the data, that's where it really becomes an IoT product. Earlier, what we used to happen was something called machine-to-machine communications and machine-to-M2M products, and we have had ICT almost for 50 years now. But it can be an IoT product if you are publishing that information onto a cloud. When you are making a car, there are essentially three aspects to it. There is something called a vehicle-to-vehicle communication. There is something called vehicle-to-infrastructure communication and infrastructure-to-infrastructure communication. For example, if it is a system that is running within the car itself, and today most vehicles have a electronic driving control unit that is there in pretty much 90% of the cars today. But if this information is published, so most cars will have something called onboard diagnostics, and with that, the maintenance guys can log into the car and see what is the what are the control flags that are there. So yes, can it be called IoT? Yes. Some people are publishing this information over a Bluetooth interface, and there's a mobile app to control it. So that is also, I'd say, IoT, right? It is great if you have a YouTube video about it. If you're
yes, he has written that.
any cloud is fine. Any cloud is fine because the data is getting published. Now, if you want a completely IoT, I mean, if you are very true to the IoT paradigm, then Firebase would need to publish a northbound APIs so that it is not only your application that is connecting to that, but anybody's application can connect to it. This is where the world is moving in terms of what is known as API as a service. So yeah, clearly in your case, what I understand is your product already is talking over a cellular network and it is sending data to Firebase, right? So it's a paradigm.
Okay, Rituraj, are you clear? Oh yes. Okay, any more questions from anyone? Any students? Anyone present here? Any more questions? Questions are always welcome. Do you want to know anything from sir? Sandhya, do you have any question? Sandhya?
No, madam. No.
Okay.
So today's audience, what has been there? Is a geophone an IoT product? Yes and no. Today, so if you look at, for example, let me bring up an example from Apple, right? Apple has a subsidiary company called ResearchKit. Have you heard of it? So ResearchKit is a platform by which ResearchKit is made available to a lot of clinical researchers, and it essentially gives access to a lot of Apple phone's internal sensors. So today, a cell phone has a gyroscope, it has an accelerometer, it has a time of flight based presence sensor, it has a temperature sensor, it has a connectivity sensor, it has a power sensor, right? So there are already various sensors that are available on the phone. If you are going to use the phone primarily for voice and video communication, then I would call it more of a communications product. But if you are using the phone to collect information from others, from either the internal sensors of the phone or from other, from a Bluetooth-enabled thermometer or a Bluetooth-enabled thermostat, then it is acting as an IoT gateway.
Okay. Any more questions? Students, do you want to know anything?
Sir, what do you mean by it's a Bluetooth enabled thermometer and a thermostat? I didn't understand it.
So I think from the late 2007-8 onwards, a lot of companies have been creating a connected product. So from the regular thermometer that you have, these thermometers come with a Bluetooth chip. Some of them are coming over Bluetooth, some of them are coming over Wi-Fi, and they come with their own app. so that when you are recording a temperature, you just don't record a temperature and forget about it. It is actually getting stored in your cell phone, uh, so that you start plotting a graph of how the temperature has changed over time. Uh, and this information can be published to a clinic, to a doctor. Right? This information can be available to you on the person as a historical record. Right? That's what I mean by a connected thermometer.
Oh, okay, sir. And sir, I have one more question, sir. Can I ask?
Absolutely.
Sir, as you told it, sir, as we all know that Bangalore is a means electronic city. So like that, there are many electrical means gadgets or industries based there, present there. So sir, is all the electrical gadgets and electronic industries there are IoT products or any different?
No, not necessarily. In order for something to be an IoT product, it must satisfy three aspects. It must either sense something or do something, right? So it must either be a relay or a particular sensor. Right? Now it could be sensing of, pretty much the way any sensor works is you convert a physical phenomena into either a voltage or a current signal. So you do that. And now there are the new generation of sensors, which are in terms of video cameras, right? Video cameras, which is doing facial recognition, which is doing people counting. And it is a sensor because it doesn't give back the video stream, it gives back a count of people. Then there is a computing environment, which means some microcontroller, microprocessor that is there. And the third part of it is the communication piece. The communication piece is either wired or wireless. If it is wired in the older industries, you will find that a lot of these are physical cables that are drawn, and you use protocols like Modbus or DALI to kind of take out these signals. But nowadays, most of them are wireless because it gives you more range, and it allows the system to be more manageable. So the communication piece is important. Now, if a device is communicating, if somebody is talking to you, then somebody has to listen. So there is also the backend system that needs to be built, which is the antenna systems and everything, which is collecting information from all these devices. So Bangalore, it's not electronic city as in a lot of electronics are manufactured there. There is a lot of manufacturing. There's even Webel here that does manufacturing, and there are large Nokia plants that were outside of China. So outside of Chennai, there is a Apple factory outside of Bangalore. So there are a lot of these assembly lines. But in order to make a product, you don't really need to have that ecosystem. You can outsource those components. You can find, these are all contract manufacturers.
No, thank you, sir. Thank you, sir.
Okay. Did that
Thank you.
answer your question, or did you have something else in mind? So it does
Sir,
not. Yeah.
no, sir. I got my answer. And sir, one more thing, sir. I think the things you told that what is means the things which are known to be as IoT has three things. And I think, sir, we can consider a mobile phone or cell phone as IoT as an IoT product, as it contains all the things, necessary things that you told just now.
Yes, but is it being used in the sense of an IoT product? Uh, when you look at an IoT product, it is in the context of an application, right? So, for example, I tell you that that I'm making a thermometer, right? Can you make me a thermometer? Now, you cannot answer that question because I have not told you why I want you to make that thermometer, or where am I going to use that thermometer. And that thermometer will have very different specifications, whether it is used for clinical thermometer for measuring if somebody has fever or not, if it is a thermometer that is used in a thermostat to control room temperature, or it is a thermometer that is used in a cryogenic environment for vaccine preservation, or it is a thermometer that is used for measuring the temperature of a blast furnace. And all of them will have different applications and a different set of sensors that you will use.
Okay, sir. Okay, thank you, sir.
So a geophone, yes, if it is being used as a gateway device, yes, a lot of phones can be used. Then it is really an IoT device. So the application comes into the picture.
Okay, anyone else wants to ask anything else? Students? Okay, so we had a wonderful lecture session by Mr. Atanu Roy Choudhury from Capsule Labs. And thank you, sir, for your excellent informative lecture on intelligence in IoT, which has covered a wide spectrum of ideas and especially highlighting upon the interdisciplinary contributions to the entire system as a whole, actually. And your very motivating lecture was in absolute coherence with the context of identifying the intellectual property component at the early stages of innovation. Actually, this was the title which was given by the MHRD, under which the webinar was to be conducted. So thank you once again, sir, from MHRD, the Institution Innovation Council of Narula Institute of Technology. And we hope to hear from you again in any other webinar session. Let us see when we can arrange one more session with you.
Absolutely, absolutely. And it's been my pleasure to talk with everybody here. I have my contact information on the screen.
Yeah.
Please reach out if there are any questions, if there are anything that I can help with. It is always good to have fresh young minds working on innovative problems.
Yes, sir, absolutely, absolutely. So students, you may please note down the email ID as well as the WhatsApp number of sir, so that you can communicate with him later on whenever you require. He is always at help. So thank you, sir, once again.
Thank you. Thank you, everybody.
Okay. So with this, I end the session here. Thank you.